This lesson is over congruence in right triangles. We're going to be using the hypotenuse leg theorem for this. The objective, students will be able to identify if triangles are congruent using the hypotenuse leg theorem. So first off, we talked about when we prove triangles are congruent, we have side, 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 we have side, angle, side, we have angle, angle, side, and we have angle, side, angle. But we do not have side, side, angle, or angle, side, side. Remember I told you don't be an angle, side, side? So why is that? Why does that one not work? Well, and again, the important thing is that the angle is not in between the two sides. If it was, then it would totally work. We have that one. Well, if you look at these two triangles, it looks like they are congruent. We have this angle and this angle. We have this side and this side. Then we have this third side is congruent to this side. So you might say, well, wait a minute, you made a mistake. They are congruent. But what if I took this line right here and I just swung it over here and I kept it the same exact length, it just goes this way. So what that would end up looking like is this. And you can see that length, when I swung it over, it's the exact same still. It's still congruent, so it just goes in a different angle. And those two blue triangles are not congruent to each other. So that's why side-side angle doesn't work. But side-side angle does work when the non-included angle is a right angle. So again, if you kind of look at how if you swing the shorter side, then it wouldn't be 90 degrees. So this 90-degree angle here, if I swing it inside, now it's not 90 degrees, now it's an obtuse angle. If I swing it outside, now it's a acute angle. The only way that it's going to be exactly 90 degrees is if it stays that way. So that's why a 90-degree angle, if you have a 90-degree triangle, you can use side-side angle. We're going to call it hypotenuse leg, and we'll talk about that in a second. A right triangle is the only kind of side-side angle that does prove triangles are congruent. So let's look at some vocab for this one. A right triangle is a triangle with one right angle. Now, if you remember, the angles inside of a triangle add up to be 180 degrees. So not only is it a triangle with one right angle, but it's actually a triangle that has any right angle, because you'll never have two right angles in a triangle. It doesn't make sense. Try to draw a triangle that has two right angles, doesn't work out. So if you ever see a triangle that has any right angles, it is a right triangle. And it obviously will only be one, but if it helps you remember. The hypotenuse is the longest side. It's across from the right angle, so it's the opposite of the right angle. It doesn't touch the right angle at all. And the leg, there are two legs, and it's adjacent to the right angle. So it's right next to it. It's touching the right angle. It's the two lines that make up the right angle. The two lines are perpendicular, if you will. So if hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of the other right triangle, then the triangles are congruent. So we have right triangles here. We have the hypotenuse that are congruent. We have the legs that are congruent. So first thing I know is that AB is congruent to DE. That's the leg. The second thing, I know AC is congruent to DF. That's the hypotenuse. But then we still need that third thing. Remember, I talked about with all the other ones, with side, 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 angle, 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 side, angle. Remember I said if you want to prove two triangles are congruent, you need three pieces of information that are congruent to each other. So if it's three sides that are congruent to the corresponding sides, if it's two angles in one side, you need three parts of information that are congruent. Well, this one, it looks like all you need is a hypotenuse and the leg, but remember the other thing you need is it's a right triangle. So this one is the same thing. It needs a third one, and that is the fact that angle B and angle E are a right triangle, or sorry, right angle. Therefore, that proves that triangle ABC is congruent to triangle DEF because of the hypotenuse leg theorem. So let's do a couple of these other problems. Are the following triangles congruent by hypotenuse leg? So We have to check those three things, the hypotenuse, the leg, and I would start with the right triangle. So it is a right triangle, so that's good. They're both right triangles. If it's a right triangle over here, it's got to be a right one over here by the linear pair postulate, adds up to be at 180. Then we know the hypotenuse, that's the longest leg, so that's congruent. And then we have this leg is the reflexive property, so it doesn't really ask this, but I like to add RT is congruent to RT by the reflexive, which means triangle SRT is congruent to triangle URT by the hypotenuse leg theorem. And sometimes I'll put hypotenuse leg. Again, it's nice if you just put HL, that's what most people do, but just make sure you memorize what that actually stands for. What about this one? Well, we have the right angle, we have the hypotenuse, we have the leg. So those two triangles are congruent by the hypotenuse leg theorem. Let's look at number 3. So again, we have the right triangle, right angles. We have this leg, and then the hypotenuse is this. So yes, they are congruent by hypotenuse leg. And this last one, so we know this hypotenuse and this one is congruent. We know this is congruent to itself, but we have no idea. These look like they're right angles, but they don't tell us that. If they don't tell us that, and if they don't mark it, there's no way to tell. So I would say can't conclude for not enough information. If you want to put not enough information, NEI, that's fine as well. But again, maybe they are congruent, who knows, but we can't tell because it doesn't say it's the right triangle. Now, the last thing I do want to say with this, and I should have added this one in the notes, is what if we had one that looked like this, and we said, let's do the same type of one. And I told you that the hypotenuse are congruent. No. Sorry, changed my mind. We'll have this triangle, and we'll have this triangle. And I'm telling you that we have right angles here. So that's perfect. And then I tell you this side is congruent to this side, and this side is congruent to this side. Is that congruent by hypotenuse leg? No, the answer is they're not congruent by hypotenuse leg because I don't know the hypotenuse. However, they are congruent because of side angle side. So make sure you make that distinction. Make sure you're aware of that. That tricks a lot of people where they'll see that, and since it's a right triangle, they think, oh, hypotenuse leg, we don't know the hypotenuse. All right, so let's do some of these proofs. So given QPR and SRP are right angles, so that's given. So let's mark that down. So we have this one and this one are right angles. And QR is congruent to SP. QR is congruent to SP. I want to prove that the triangles are congruent. So the first thing I want to do is the given. QPR and SRP are right angles, and QR is congruent to SP. That is given. Don't have a lot of room, but that's good enough. Again, always put the given there because you'll at least get some points if you don't get anything else correct. Hopefully you will. So we have that they're right triangles. We have that the hypotenuse is congruent, but now we need this one is congruent to itself, PR. Again, I said this a while ago, but make sure you realize that reflexive property happens a lot in these problems. So if you still don't know what that is, you need to be asking. So that means I know that triangle SRP is congruent to triangle QPR by the hypotenuse leg. Again, we know they're right angles. They said that. We have the hypotenuse. Now we have a leg. That's the 3 parts of information we need. How about this one? P is the midpoint of RB, Angle S and angle Q are right angles. That's marked on here. And angle RS and TU are congruent. So those are marked as well. So again, I'm not going to waste your time with this because you can write this down, but this is all the given. Again, on a test, I would definitely take the time to write that down. I just don't want to waste your time more than I need to. So that's our step one. Our step two, I might as well go ahead and make sure I put RT is congruent to TV because of the definition of midpoint. If T is the midpoint between R and V, that means these have to be congruent to each other because it cuts them in half. So we have a right angle. So that's one thing we need. That's the given. It tells us that RS and TU are congruent to each other. That's one. That's the leg. And then we just prove the hypotenuse is congruent. So now I know triangle RST is congruent to triangle TUV by the hypotenuse leg theorem. How about this one? So we have BE bisects AD at C. So BE, that's this line, bisects it right here at C. AB is congruent to BC. AB is congruent to BC, or sorry, is perpendicular to BC, and DE is perpendicular to CE, and AB is congruent to DE. AB, oops, sorry, wrong one. AB is congruent to DE. So again, I'm going to cheat with this one. My step one is my given. Again, please on a test, write that out. Honestly, on homework, if you don't want to take the time to write it out, that's fine. Just don't get that bad habit. So since they're perpendicular, they're 90-degree angles, so I marked them on there, but you might want to take a step to explain that. And again, technically, you don't really have to, but the more you can tell me, the more you know, the better. So right now, we know they're perpendicular, but I would make sure I'd say angle B and angle E are right angles because of the definition of perpendicular. Now again, you might not put that down, you might skip that because it's kind of a no-brainer, but so far every time I've done this, I've said it's got to be a right triangle, and that's not a perpendicular triangle. It kind of is, but it helps to state that. If you were actually doing a formal proof, you would definitely need that. But since we're doing a little bit of an informal style, we can be a little bit flexible. So we know they're right angles, so that's good. I know that AB is congruent to BC, that's fine. And BE bisects AD. So that means if it bisects it, it cuts it in half, which means AC is congruent to BC. And we know that because of the definition of bisector. And again, technically it's a segment bisector, but that's okay. So now we have the hypotenuse is AC and CD. We have a leg and it's a right triangle. So I now know triangle ABC is congruent to triangle DEC by hypotenuse leg. Decide whether there's enough information in the given to prove that the triangles are congruent. Explain your answer. Now notice it just says explain if they are congruent. It doesn't say it has to be hypotenuse leg, so make sure you keep that in mind. So we have this angle, or sorry, this side is congruent to AC. We have the reflexive property, so we have a side, an angle, and a side. That's not the hypotenuse leg. We don't have anything with a right angle. I know it looks like these are a right angle, but we can't tell that. They don't tell us that. They don't tell us any information that would hint at that, so we have to assume that it's not. So that means triangle ABD is congruent to triangle ACD, and that is the side angle side. Now again, if you look at these, it's not necessarily a right triangle. We don't know that. They don't tell us that, so we can't just assume that. So I have this side, we have this angle, and we have MO is the reflexive property. So we have side, side angle. So not enough information, or you can't tell, or you can't conclude. If you just say they're not congruent, I can accept that, but maybe they're congruent, we just can't tell, because again, there's no side, side angle. If that angle was this angle over here, then we'd be in business, because the angle is in between our two sides, but it's not. Since that angle is not in between our two sides, we can't do anything with that. So let's see, so they tell us they're parallel. So that means this angle and this angle are congruent because they're alternate interior. Again, if you kind of think of these two as the parallel lines, this is your transversal. You can do the same thing if this was your transversal, this angle and this angle. So let's erase this and make it look a little bit nicer. So I know this one and this one are congruent. This one and this one if we need it. And we have vertical angles in the middle. So there's no angle, angle, angle. That one doesn't make sense. But we do also have this side. So you could do triangle ROS congruent to triangle ROS would be TOU. And it all depends on what you look at. You could use angle, angle, side, or angle, side, angle. It all depends on which angles you want to use. This one, we do have a right angle. We know the hypotenuse is congruent, and this is the reflexive property. So that one definitely is. Triangle RST is congruent to triangle RUT by hypotenuse leg. Since it's a right triangle, the hypotenuse and the leg. Let's look at this one. So this one's a different reflexive property. The bottom of this triangle is the same as the bottom of the other one. So that one's congruent. So we have the right angle, right angle. We have another angle, and we have a side. So we have angle, angle, side. So now, even though these are right angles, that doesn't mean we're going to use hypotenuse leg. We have angle, angle, side for that one. So A, B, C is congruent to triangle D, C, B by angle, angle, side. Oh, geez, this looks confusing. So this line is parallel to this line. So we have this angle and this angle are congruent because they're corresponding. Then we have let's see, we have this line and this line are parallel, so we have corresponding here as well. And so we have two angles. I don't think we have anything else that we can prove. So we might be missing something here, but I can't tell the other angle, and we don't know anything about any sides. They don't give us any sides that are congruent. Just because lines are parallel doesn't tell us anything about the lines being congruent. So I'm going to say not enough information on this one. For what values of x or x and y are the triangles congruent by hypotenuse leg? So again, we kind of did this earlier where what would the x and or y be to make sure they're congruent? Well, this one, the hypotenuse is the x. This one, the hypotenuse is 17, so x would have to be 17. If it was 17, then hypotenuse leg. It's a right triangle, and we know the leg. This one, you know the hypotenuse are congruent because they're both 4.5. We know it's a right angle. So this leg has to be congruent to this leg, which would be x has to be 3. How about this one? So again, the hypotenuse has to be congruent, so 13 has to be equal to 4x plus 1. Then solve for x. Don't make that harder than it is. X is equal to 3. And then the leg has to be congruent. So we have 2x plus y is equal to 8x minus 2y. But here's the thing. It looks hard, but we know the x is already 3. So go ahead and plug that in. So we have 6 plus y is equal to 24 minus 2y. And solve this just like normal. I'm going to add 2y. That's 3y is equal to, 6 plus 3y is equal to 24. Subtract 6. 18 15, I believe. I should probably double check that in a calculator. So we get y is equal to 6. Same thing as the next one. The hypotenuse has to be congruent. So we have 2x plus 1 is equal to x plus 3. So we have x plus 1 is equal to 3. X is equal to 2. And then the next one, again, these have to be equal to each other, these legs. So we have x plus y is equal to 3x minus 3y, but we know the x is 2. So it's 2 plus y is equal to 3 times 2 is 6. Go ahead and skip a step there. Let's add 3y. 2 is equal to 4y is equal to 6. Sorry, 2 plus 4y is equal to 6. Sorry, going too quickly. 4y is equal to 8. So y is equal to 2 as well. So that's the end of the notes. If you have any questions, make sure you're emailing me or make sure you're asking me.